Assalamu alaikum. Here we have another question on erratic motion and dynamics. We have the AS graph given for a car that's accelerating and decelerating. So this is the acceleration phase and this is the deceleration phase. Okay, construct the VS graph from this information and also find this S prime. The information here being given is that the car starts from rest, okay, and travels until it stops. So the car stops at this point and also starts from rest. Okay, I will divide this given graph into two segments. That's the first segment and that's the second segment. So here I have this segment 1 and this segment 2. Okay, for 1, I have A to be a constant, which is just 6 feet per second squared. Since we have the AS graph, I mean the A on the y-axis and the S on the x-axis, it makes sense to use this kinematic relation, which is A equal V dV over ds. Remember, this relation is just a result from A equals dV over dt. Then we use the chain rule by inserting the S variable. So dV over ds is ds over dt, right? And ds over dt is simply V. Okay, so now I have, from the first segment, I have 6 equals V dV over ds. And let me separate these variables. I will have 6 ds is equals V dV. Now we can integrate both sides just like that. For the s, since we are starting from 0, it's 0. And for the v also, we start from 0, so it's 0. I'm going to any position within the first interval, so just to s. And for the v, I'm going to any speed within the first interval, v. And now, finding this integral, I will have 6s is equal half v square. And I want to solve this equation for v, since I want to build the VS graph, right? So now I have v to be the square root of 12s. So that's my first velocity function for the first segment. For the second segment, I have something similar, but this time the car is decelerating, so I have a negative acceleration. So I have A is just minus 4, negative 4, so I have, let me apply the same steps, minus 4 ds is equal v dv, okay, and we will integrate also both sides. But here we have to be careful about the limits of both integrals. For the s here, if you look at the graph, we no longer start from 0, we start from some position, right, which is in this case 1000. So the lower limit for the s will be 1000 and until any position within the second interval until s. And also for the velocity, it's no longer 0, I mean the starting point, it is some velocity. And how to find that? We are looking at this point, right? So at this point, I would like to find what was my speed at 1000. So now let me, using the first velocity here, since I know it is 12, the square root of 12s, let me replace s by 1000. So now here, let me just do it on this side. V at 1000 feet is the square root of 12 times 1000. Okay, so now let me do this calculation. Okay, I got it's almost 110 feet. So that will be my lower limit for the velocity, 110 feet per second, and until any velocity within the second interval. Okay, let me carry out this integral. It will be minus 4s minus 1000, okay, equal half v square minus 110 square. So what is this number? 110 square. 110 square. You know, this number is not exactly 110. This number is almost 109.5. So let me take, 4 significant numbers. So I will just take here 4 significant numbers. 109.54.5. So this now here will be the square root of 109.5, almost it's 12,000. Okay, solving for v here, I will have v to be minus 8s plus 20,000. Okay, so just solve for v, square root. Okay, so that's my second velocity for the second phase, for the second segment, right? So now since we have both, let me now immediately draw the VS graph. Okay, so that's the V and that's the S here. For the first one here, it is simply the square root of S. Let me remind you what the square root function looks like. If you have here y and x, the square root function, so if you have y equal root x, it would be something like that. Okay, so for the first segment, I have something like this. Now for the second segment, I have also a square root function, but now we have a negative multiplied by the s. So it means now that my curve would start from somewhere, maybe on the left side, on here, right? But we have then this plus 20,000. So it means now the curve will start from somewhere here along the s, right, and connects with this point. So it will go maybe something like that. Okay, and let me put my intervals. I mean my numbers here. This is 1000, and this is simply S prime. Okay, so that's it for the VS graph. The question asks to find this S prime, and the question says also that the car stops at this point, right? So travel until it stops. So it means that the velocity here is 0. So what we can do now, we can say that velocity is 0 equals 0. Okay, velocity is equals 0 when at S prime. So in other words, now I'm going to replace S by S prime and set everything here to 0. So we have minus 8 S prime plus 20,000 square root equal to 0. And I'm just going to solve for S prime. Okay, so let me do that here. We have 20,000 divided by 8. So I got 2,500 feet. So that was my S prime. Okay, I hope you found this video useful. If yes, please share and like the video, and let us know in the comment section if you have further questions. Wishing you a good luck. Thank you.